Okay, so the hardest ones on the test are going to be stretches. And if they have a picture like this, you got to know, okay, what's the base? It is a square root. So it looks like this. And now I have to decide what to do with it. Do I stretch it up, down, left, right? And these can be confusing. This one's fairly easy. Can you see that compared to the parent one, which, by the way, would have been here? And remember, 1, 1 is a common dot that we use. Over 4 up 2, and over 9 up 3. That's these square roots. Square root of 9 is 3. Square root of 4 is 2, etc. So compared to this one, can you see it's been stretched up? All right. And then how much has it been stretched up? That is, in this case, it's not just always going to be double, but we did that a lot because they're easy to see. It went up 1 compared to up 2. See, this one's twice as tall. That's why it's a double. This one went up 4 instead of 2. This one went up 6 instead of 3. So they are double what they used to be. So it's obviously a doubling situation. Now, in some cases, we would actually put a 2. Because if it's in the inside, then it does the opposite of what you'd think. Is this kind of a left-right thing or an up-down thing? So then it's on the outside. So then that negative, or not negative, the 2 should go on the outside. And do I trust it or not trust it? Trust it because it's on the outside. So I can put a 2 here, and that would give me a right answer. Raise your hand if you followed that and you're good with that one. Okay, good. It's going to be a little harder as we move on. This one, don't say it. I want you to write what you think the answer is on your notes. Don't have to draw the whole picture. I know that's kind of complicated, but I hope you're seeing that it's not an up-down thing that happened. All right, so you start by writing out y equals, and which one is it? Is it's a squared absolute value or square root? Squared. So then I need an x squared. Now I need to know about inside and outside. If I don't put any parentheses, then there are little imaginary parentheses right around the x, because that's what the x is like an empty parentheses you can drop things into. All right. So now, where should I make my move? Is this an up-down or left-right thing? Left-right. So it's on the inside, and so I need to extend this out a little bit. And then on the inside, should I make it double or triple, or what do you think? Double wide. So if I put a 2 here, this is the most common mistake I will get. Why is it wrong? Because that would actually make it narrower. And if I want to make it wider, I do counterintuitive thing, which seems like it's going to be half as wide, but it actually makes it twice as wide. All right. Now, if you, I showed you that with your graphing calculators before. We actually put these numbers in. We saw the thing actually do the opposite of what you'd expect. And otherwise, if you needed to like prove this on paper, you'd go like this. You'd say the original point should have been at over 2 and up 4. That would be normal for a parabola. Okay, that would be like the one that goes like this. Over 1, up 1, over 2, up 4, over 3, up 9. There's my normal one. Over 2, up 4, and 3, up 9. The black dots there, I better make them bigger, are my normal parabola. And this one has gotten wider. So instead of over 1 and up 1, it's over 2 and up 1. See, it's every point just got moved over. Twice as far as it used to be. Used to be over 2, now it's over 4. Used to be over 3, now it's over 6, etc. Okay. All right, if I had to prove that I had the right equation here, what I could do is take a spot like right there, and it says 4 comma 4 should work in this thing. If I put in a 4 here, do I really get 4 for an answer? Yeah, because half times 4 is 2. 2 squared is 4. It actually works. Okay? So if you ever want to know if you've got the right answer, you can check it. That's what I'm trying to say here. So if I think that I've got the right answer after I do this, then I can take any point on here. I'll try this one now. And 6 comma 9 should fit into this. If I put in a 6 for the x, I should get a total of 9 out. What's 1/2 of 6? 3 squared is? It worked. So checking your work is just so smart. We do this in pre-calc too. A lot of times, with a really complicated problem, you get these 2 answers. And a lot of times, one of the 2 answers won't work. And people will put down both answers. and they're wrong because one of the two answers doesn't work. You have to go back and put them in and see if they actually work. So double checking yourself is just smart. You can be sure you've written the right answer by just checking a point, dropping it in. All right, good enough on that one. Let's try this one. It's definitely harder. Look at it very closely and write down what you think the right answer is. Don't say it, please. Write it down. And I'm going to put an answer up on the screen with my Centio Dealy Bob here. And I'm going to ask you, this is an instant true-false question. I'm going to ask you if you think that what I write on the board is the right answer. Okay, here's what I'm going to write. I think it is a square root. And I think that on the inside, I think it moved over 1 to the right. So I'm going to put a +1, or no, -1 would be to the right, okay? And then I think it got, I know it got flipped. I think it's an up-down flip. If I think it's an up-down flip, I'm going to put this. And then I think to get down there, I actually have to flip it both ways. So I'm going to put a negative right there. And now I've flipped it both ways. Okay, I want you to give me your opinion. True or false? Don't say it. Type it in. True or false? You don't have to sign in here. All right, that's weird. If your clicker's not working, just turn it off. Turn it back on again. To find a class. I'm going to hit pause while we were recording here. Okay, the things that are wrong with this. Yes, sir. And this is one of the reasons why 96% of the kids said it was false, because say that again?
The -1 should be +1.
All right, so you think this right here should be a +1, that it should have been moved to the left? All right. It's not really, I know what you're thinking. You're thinking about this negative being distributed, but there's a better way to say it than that. Let me show you what I mean. I think we should say that it needs parentheses. Do you know what I'm talking about? All right. So if I look at this one and I need to have parentheses around this, anytime I have a negative here, there better dang well be parentheses. Now, whether or not that should be plus or not, we'll check a number. Remember how I said we could test a point in the answer and see if it works? But is there anything else wrong with this thing? I think there's something bigger picture wrong with this thing. Yes. You think this thing has been stretched or squished? First of all, you're right. The question is, though, is it stretched left-right or is it squished left-right? It's squished. You're correct. See, normally you should be going over 1 and down 1, and it doesn't go far enough. It only goes halfway there. And normally you should go over 4 spots and down, and in this case, we only go over 2 spots and then down. You see how it's kind of been squished? All right. All right, hold on just a second. I got to get that purple thing back. Oh, man. My purple line's gone, but that's okay. All right, so you're right. That last point's messed up. That last point shouldn't be there. I wonder if I can just get rid of it. You are correct. That is a mistake. This should be, instead of over 9 and then down 3, if I'm going to stick with the same thing that's going on here, it should go over 4.5, right? Yeah, over 4.5 and down 3. Oh, that's right. You're right. 5.5 down 3 because there we go. There. Okay. Thank you. That actually helps a lot because it was kind of not looking right to me, and now it feels better. This has been stretched. Okay, stretched with a, that's always tricky to say. Is it stretched or shrunk? I agree it's more shrunk, but I was going to say stretched with a factor of 1/2. So if I'm going to actually put in a half, though, it won't do what I expect. So you were right when you said to put a 2 in there. Good job. All right, so is this right? These can be really tricky. How do I know for sure? I just told you a second ago. How do I know for sure? Test the point. All right, so let's test this point right here. That point is at -3, comma, -2. If I stick in x is -3, I should get an answer of -2. What's -3 minus 1? -4. What's -2 times -4? -8. What's the square root of negative? Wait, that's kind of ugly. Oh, it's +8. What's the square root of 8? It's, well, agreed. This is not right then, is it? It must have to be a +1. So now we have to fix this to be a +1. And now I can double check it. Okay, -3 plus 1, -2. What's -2 times -2? +4. What's the square root of +4? 2. And then I make it negative, and I get -2. Now it works. Whew, that was a tricky one. All right, so the final answer should be, I'll rewrite it, y equals negative on the outside, square root of -2, and in the inside the parentheses, x plus 1. Now, I know some of you are saying, but this has been moved to the left. How come? Oh, it has been moved to the left, so it should be a +1, shouldn't it? Okay, it's counterintuitive on the inside, and so it can be goof your head up with, wait a minute, it's moved to the left. It seems I should be -1. But that means you use a +1. Okay, and how can you ever be absolutely positive? You take a point, you stick it in and see if it actually works or not. And if it doesn't work, you know you messed something up. All right, let's try one more. Try this one, and I'm going to write out what I think the answer is, maybe, and then I'm going to have you answer an instant yes, true, false kind of thing. Just a second, I have to go back to the screen and stop this question, otherwise it won't let me go on. There. So, I know it's got to be a x squared thing. I'm going to leave some room there just so I can do some stuff to it. I think it's been flipped up, down, so I'm going to put a negative on the outside. Then, I think, oh, it's been stretched, sneaky. Definitely been stretched. Looks like an up-down stretch. Looks like instead of going over 1 and down 1 like it normally should, it goes down 2, so I'm going to say it's 2, so I'm going to put a 2 out there. And it hasn't been moved left or right at all, so I don't need anything else in there. All right, that's it. Tell me, true or false? Got a question or an answer? All right, just give me a second here. I got 18 people have answered. Yeah, I think some people haven't hit finish. All right, there we go. We're getting really close now. And I'm not going to wait forever. Okay, so I hit show. And it says, I know the people at home can't see this, but it says that 82% of the kids think this is false. 13% think it's true. Usually, a group like this with a lot of smart kids in it are usually as a group, right? And you're right, it's false. So what is wrong with it, though? Yes, sir. You think there should be another negative. Where? Ah, like this, like a -1 like that. Now, if I want to, I hit stop this question, and it won't let me insert a question on the same page, so I'm going to just go up one page and insert a question there. Instant true, false. Now I'm going to go back, and you can answer the question even though you're looking at this screen. Answer it now. Is it right now? If your life depended on it, what would you do right now? Stick a point in. If my life depended on it, I'd probably stick in like 2 or 3 points and make sure that they were all working. But since your life really doesn't depend on it, I might stick in 1 just to see. 1, 3 is a point I see right here. So if 1 comma 3 works, this should work probably. I'm going to stick in a 1. I'm going to stick in a 3. You're right. Thank you. Should be negative 3. Okay. So and I'm going to double check this, and it's 1 squared is 1, and negative 2 times 1 is negative 2, minus 1 is negative 3, and it works. So seeing your results on this page, I hit stop this question because that's close enough. See if I can drag this thing out. Everyone, let me just drag it. Ooh, you're right. I'll try that. Yes, there it is. Most of you guys were right. It was a true answer now. So, okay. Moral of the story. When you're doing these problems, watch for the stretches and shrinks. They are tough ones. Can you be sure you're right? Yes. By checking a point. It really, really helps. Okay. Now, I have to only teach you one more thing for today because we had kind of a light day scheduled for today because there's lots of weird things happening today with testing in the building. Doesn't really affect the freshmen very much, but the whole rest of the classes are doing this big test called the plan test. Anyway, so it's kind of a light day, but I wanted to introduce one more thing. That's a new parent function. You knew this one, and you knew this one, and you knew this one. Notice they all go through the spot 1, 1, by the way. And y equals x to the third. Do you think that'll go through 1, 1? Yeah, because if I stick in a 1 here, wouldn't it give me a 1? Yep, so it goes through the point 1, 1, 2. But it looks totally different. Would you grab your graphing calculator and graph y equals x to the third? If you do not have your graphing calculator, would you please borrow one of mine rapidly? Right here. I have 3 of them if another person needs one. Okay. Y equals x to the third, and I would use a little caret button. A little caret button is this one right here. Oop, guess you won't let me draw on that. There we go. Okay, hit graph, and it sort of looks like it's half a parabola going up and half a parabola going down, sort of. That's one way to think of it. Now, what are some main points, the parent points on this thing? Do you agree 0, 0 is on it? All right, so then I could put 0, 0. Now, you can just plug in numbers and make it happen. If I stick in a 1, 1 cubed is 1. That works. If I stick in a 2, 2 cubed is not 4. What's 2 cubed? 8. And unlike the other graphs, you know when you have square something, the negatives just disappear? With this, if you stick in a negative, like negative 1 cubed, it means negative 1 times negative 1 times negative 1, and the answer is negative. That's why it goes down on that side of the graph. Negative 1 goes with negative 1. And negative 2, when I stick it in here, negative 2 times negative 2 times negative 2 makes negative 8. And those are the key points you'd need to know for this graph. Now, yeah, you could go farther, and you could say 3 goes with 27, but you're not going to be able to graph it. It's so big that it won't fit in a normal graph. All right? So, I bet you're going to be able to process this really easy. If I take this, and I do this to it, what do you think happens? Which is right 3. See, this is the nice thing about functions. Once you learn how they work, then you can add a new function, and it's like, oh, that's easy. I just move it to the right 3 because it's the same deal. If it's on the inside, it goes left, right. If I stick a negative there, what happens to the whole thing? Flips. Which way? Up, down, or left, right? Up, down. All right. So let's, on your calculator, let's graph both this one, and let's just do the opposite of it. So negative x cubed. Negative, not a minus, sorry, negative x to the third. And I hit graph. And it flipped. That is a flip. Up, down. It feels weird, but it's right. It worked. All right. Now, if I flip it, if I were to do a left-right flip now and graph that on top of these other two, wouldn't it pretty much do the same thing? You know what I mean? It would be on top of one of these. I wouldn't even be able to tell I'd flipped it, right? Exactly. A left-right flip looks exactly the same as an up-down flip. Let's just think about that for a second. Why? Why would it matter if I put the negative inside versus outside? I get the same exact thing. If I put a negative on the outside versus putting a negative on the inside. Yes, you're going to times it by itself 3 times. And so whether or not the number is negative is what I'm going to make it the opposite of whatever its answer was going to be. Whether I put the negative outside or whether I put the negative inside. That's why you get the same exact graph for them. So like if I stick in -2 into either one of these answers, it's going to come out the same. Either one of these problems. Okay, so let's, I think that's it. I think that's all you need to know. So what I want to do is give you time in class to work, because I know a fair number of people had questions about the back side of this packet, and it was fairly big. I warned you it was going to be kind of big. And you should have started on it early. But anyway, if you didn't finish it, because it is due tomorrow. Okay, and for those of you that needed help, I'll be here and I'll be able to answer questions for the next 15 minutes or so before you leave, or 20 minutes, whatever we got left. And then the X cubed thing I just showed you, I just want you to do a few of those so that they stick in your head. And that's the front side of this worksheet, just the front side of this worksheet called X cubed investigation.